So a logarithm is just a function that outputs the exponent. So you know right here that 3 squared is 9, correct? And here's the exponent. What is the exponent? What number is the exponent? 2. And what is the 3 called here? The base, correct? Okay, so look at how it's rewritten here. This is called log base 3. There's our base number of 9. Log base 3 of 9 is equal to the exponent that would give you the 9 with a base of 3. So a log function, what it does is it outputs the exponent. If you don't know the exponent, you can use a log function. Does that sink into everybody? See, this is the base, there's the exponent. What a log function does is you can put in the base and the value of whatever you're trying, and it'll give you the exponent. Equals 2. So 3 squared equals 9. Make sense? Think about that for a second before we move on. Okay. You're going to be working with these log functions. You're going to go in between logarithm form and exponential form. You've got to be able to be pretty comfortable with that. So this is exponential form. This is logarithm form of the same function. Something interesting back there on that table. All right. Alex is like, All right. Logarithm form. So here we're going to go between the two forms. So here it's in log form. So remember, the lower number is considered the what? Of the power. The base, right? Log base 2 of 32 equals 5. So what you do is you just kind of look at it as arrows. I'm going to write 2 to the 5th equals what? 32. So this is logarithm form, this is exponential form. Be comfortable with going between them. So here is exponential form. If I were to write it in logarithm form, what is the base number? 10. So I would write log base 10 of, what would be the next number I would put? 1 equals 0. It equals the exponent. Okay? Now, log base 10 is special. You won't always see it written with the 10 because it's such a commonly used function that sometimes it'll just be written like this. Log base 10 of 1 equals 0. They won't even put the 10 in there. Same thing, okay? And that's what's on your calculator. Log base 10. So we'll get to that later. All right, let's write this in exponential form. What's the base number? So I'm going to go 9 to the what? 9 to the 1 equals what? 9. Easy enough? Okay. It doesn't matter that the base number is a fraction. It's cool. We can have a fraction. So it's going to be 1/5 to the negative 2 equals what? And do we know that to be true? Yeah, we do. Okay. How do you feel about that? So that's going to be part of what you're going to be doing is making sure you know how to rewrite them. All right. Then the next thing, so this is one thing you have to do. The next thing is evaluate the logs, meaning find the exponent. Now, it's not set equal to anything, and that's what we're trying to find. So I often will just do this, equals x. I'm trying to find that exponent. So now I can rewrite it in exponential form, and I could say 3 to the x equals 81, right? Now, I can't do much with this right now. You might know the answer in your head. That's okay, but sometimes you won't. However, I can write 81 to have the same base here, right? What is 81 written with a base of 3? Does anybody know? 3 to the what? Gives you 81. 4. So if you rewrite them with the same base, and these values are equal, then I can tell right now that x has to be what? 4. So this tells me that x is 4. Because I'm saying these are equal, that means that x has to be 4. right? Okay, let's do another one. So set it equal to x. And then I'm going to rewrite it in exponential form. So it's 1/4 to the x equals 256. Now, this is a little different, but I can write them both with a base of 4. How would I rewrite this so it has a base of 4? 4 to the negative 1x? How about that? 1/4 is the same as 4 to the negative 1. Remember that? Then I set 256, the base of 250, with a base of 4 is 4. And that little purple sheet might come in handy that I gave you last chapter. 4 to the 4. I don't think you'll have any such big numbers on the test, so. Okay, so now I have the same base. That means the exponents have to have an equal value, correct? So I would say negative 1x equals 4. And then divide by negative 1, so what is x? It's kind of fun. Okay, you don't believe me. All right, let's set this equal to x if I have to evaluate. All right, 10 to the x equals 0.001. Isn't that scientific notation? So how would I write it with a base of 10? 10 to the what? I heard it. Somebody said it. Negative 3. Okay? So what is x equal to? Now, we have log base 10 here, don't we? That's a very special number that is used all the time. If you go to your calculator and you push the log button, it is base 10. Everything on the calculator is base 10. Okay? So if we put in 0.001, we get negative 3. You can only do that with log base 10 on the calculator. Should I say that again? So, all right. Let's do one more. Set it equal to x. You guys try this one on your own. Try it on your own. Right here. It's a 1, isn't it? So you're going to write that 1. And then you're going to set 6x equal to 1. I'm kind of running out of room here, so I'm going to go up here. 6x equals 1. Divide both sides by 6. I had to write 64 as a base of 2. And that's 2 to the 6. You with me? Okay. And then this has an exponent of 1, so I set 6x equal to 1, and x is equal to 1/6. And if you put that on your calculator, 64 to the 1/6, you would get 2. Cool? All right, let's move on. There's so much more fun to have here. All right, a common logarithm, which I've talked about already, is a logarithm with base 10. It is denoted by log base 10 or just plain log. Either way. These are the numbers. This is what you can use your calculator for. That's what's programmed on your calculator, is anything that's log base 10. If it's got a different base, you can't use your calculator. You got to change it to log base 10, which we'll get to. Okay. Natural logarithm is a logarithm with base e. It can be denoted by log base e, but mainly it's ln here. Did you see ln on your calculator? Yeah, that's what that comes from. That's log base e, and the base number is e. So if you have that, then you can just use ln to do calculations on your calculator with. Make sense? No? Well, let's practice this. So use a calculator to evaluate the logarithm. Is there a number here? A base number written? No, so that tells you it's got to be base what? 10. If it's that case, that's the case, you can use your calculator to evaluate it. So go for it. Just push log and 0.85. And that's your answer right there. Negative 0.0706. Let's just go that far. When there is no number, it's log base 10. Okay? Now, ln means that we had this, log base e of 22. This and this are the same thing. But log base e is programmed in your calculator as ln. So you just push ln 22, and that's the value of that. So this is saying, let me just show you what this means. This means if I write it in exponential form, e has been raised to the what number? 3.09, and that equals 22. That's what that means. E to the 3.09 is 22. Okay? Can't tell on your faces. What? Before, switch x and y, then you've got to write it in its opposite form. And then you solve for y. So, right here we have this, y equals 8 to the x. So what's the first step? Switch x and y. Switch x and y. Now we're going to rewrite it. What's the base number here? 8. So I'm going to put it in log form, so it's going to be log base 8 of x equals y. It always equals the exponent. The log function always equals the exponent. Okay? So is that solved for y already? Yeah, so this is the inverse. That's the inverse of that. Funky, isn't it? Okay, let's do another one. You see ln, you should automatically in your head think I can write that with log base what? E. And that's what you should do first. Well, actually, first let's switch x and y. So I switched x and y. Now, in order to write it in exponential form, I'm going to write it in log base e, because ln and log base e are the same. Okay, now we're going to switch to exponential form. What's my base of my my power? It's e, right? Okay, what's the exponent of my power? X, because the log function puts out the exponent. And that equals this stuff. Now I need y by itself, so what would be the last thing? Add 4 to both sides. And it just looks like this. E to the x plus 4 equals y. And that's the inverse. They want to analyze it and make it way harder than it needs to be. So let's read what it says. Simplify the expression. If the base number of the power and the base of the log are equal, they cancel each other out. They're basically inverses of each other. The answer is the exponent you are left with. So here's a power. What's the base number of this power? 5. And what's the base number of the log? 5. So if you were to simplify this, these two cancel out, and your answer is just x. Totally easy, okay? Because they're inverses of each other. So just like we could prove it if we wanted to do all this over again, and each side you'd see that they're inverses of each other. So it's just like 3/4 and 4/3 basically multiply together to be 1, right? It's the same thing. Inverses just cancel each other out. Okay? So here we go. What's the base of this log? 4. So I'm going to write this, log base 4 Can I make the base of this power a 4? It would be 4 what? 4 squared, and the x is still there, right? So I wrote the log base 4 over, and then I wrote 16 to the x as 4 squared x. Make sense? Now, once you've achieved the same base for both the log and the power, they cancel each other out. And what is your answer? 2x. That's simplified. How about this one? It's just going to be, this is the same base, so it's just going to be x. Simplified as x. Okay. The base here of the log is 3. The base of this power right here is 27. Can we write 27 with a base of 3? Yes. Yes, so I'm going to write log base 3, and I'm going to rewrite 27 as 3 to the third, but I have to have that x there. And then they cancel out, and what's your answer? Okay. Okay, now wait a minute. There's no base number here, but it's what? 10, right on, it's 10. Okay, and I can write 100 with a base of 10, which would be what? Okay, they cancel out and your answer is 2x. Not bad, right, for that part?
Yes.
Last but certainly not least is graphing. Okay, all right. It's sort of a process, but it's not bad. It's slightly different because you're going to have a vertical asymptote here instead of a horizontal asymptote. So that's the only thing that's really different. The graph of y equals log base b x minus h plus k has the following characteristics. The line x equals h is a vertical asymptote. Well, any x equals equation is a what kind of line? Up and down, though, vertical, right? It's always a vertical. So the line x equals h is going to be the vertical asymptote. So we're going to keep track of that in a second. Here's h right here. The domain is always going to be x is greater than h because we're going to have this vertical asymptote, and you'll see it in a minute. If b, the base number, is greater than 1, the graph moves to the right. If b is between 0 and 1, moves up to the right. Here it moves down to the right. I'm going to show you all this. I'm just reading this right now. Think exponential form and pick a few convenient points. Okay, so first of all, let's identify our asymptote in this function. What is k in this function? Or excuse me, what's h in this function? I said it wrong. What's h in this function? Is there an h? What value is it? 0. So my asymptote, this is going to be the first thing I'm going to do. Always identify your asymptote first. It's going to be x equals 0. And that is a vertical line, so let's draw it. There's my asymptote. X equals 0. The second thing I'm going to do is identify which way my graph is going to go. Looking at the base. What's the base number here? 2. Is that greater than 1? So my graph, once I get my points, I know my graph is going to go up and to the right. So these are just decisions I make before I actually get my points. Okay, the third thing I'm going to do is I'm going to convert this to exponential form so it's easier to get some points. So what would it be? This is my base. What's my exponent? What's my exponent? Y equals x. Okay, I can get some points. You have the mathematical capability to do that. So pick some easy points, but start with y. Start with y, which is a different way of thinking. What if y was 0? What would x be? 1, correct? What if y was 1? What would x be? 2. Let's just do one more, which is easy. What if y is 2? What would x be? 4. I have 3 points now. So let's graph them. over 1, up 0, over 2, up 1, over 4, up 2. I've already decided that my graph is going to go up and to the right, and it's going to go along the asymptote. Don't forget that. It goes along your asymptote, comes up, through your points, and goes to the right, like that. Now we just have to state the domain and the range. All my x values are going to be greater than what? 0. And what did it say right here? The range is always going to be what? All real numbers. Not too bad. It's just a process. You just have to kind of learn these little steps and you'll be all right with it. Let's do a couple more and then we'll be done. Okay. What's your asymptote here? Yeah, h is 0, so my asymptote is x equals 0. So I'm going to draw that. X equals 0. Is my base bigger than 1? No. So it's going to go down and to the right. We'll go down and to the right. Do you necessarily have to write this always? No, but I just to get you started here. Think about it, okay? Then, what do we do next? We wrote it in exponential form. Write it in exponential form. So, 2/3 to the y equals x. Okay, now I'm going to try and come up with some easy points, but I'm going to start with what coordinate? Y. Start with your y, because it's easier, right? So let's plug in 0. What would that be? 1. We could plug in 1, I guess. What would 1 be? 2/3. It's not too bad. It would be easy to do -1 as well. What would -1 be? Think about it. What would it be? 3/2. It's the inverse, 3/2. Okay? So let's plot these points. Over 1 up 0. Over 2/3 up 1. Over 3/2, which is 1 1/2, down 1. And now we said our graph is going to do what? Come down and go to the right. We've already decided that, so it's a sketch kind of looks like this, sort of. What's the domain? X is greater than 0. The range, all reals. Now, of course, we have to add a h and k in, and then we'll be done. So let's do an h and a k. All right, what's the asymptote in this function? It's your h, remember? So was that a positive 4 or a negative 4? Positive 4. Asymptote? X equals 4. So let's just sketch that right on our graph. Remember, it's a vertical line through 4. What's my graph going to do? It's a base bigger than 1, so what's it going to do? If it's bigger than 1, it's going to go up and to the right, okay? Graph will go up and to the right. Because the base of 6. So what was the next thing that we did? We did it in exponential function, but when you do that, you just use the basic log function, okay? So if I just use this, and we consider this as a y, because we can, how would I write that in exponential form? 6y equals x. So we're going to do that first, and then we'll consider the shifting. So let's come up with some points. Let's just do our basic points. What would 0 be? It would be 1. What would 1 be? If I plugged in 1 for y, it would be 6. Okay? Now, My H and my K causes my graph to do what? My graph to do what? Shift which way? Right 4 and up 2. So I'm going to add 4 to my x coordinates, correct? Plus 4, plus 4. And what am I going to do to my y coordinates? Add 2. So I can write my new points. Would be 4 and 2. I can add 5 and 2. And 10 and 3. So this is what I'm going to plot. I think we go off the graph a little bit. I should have had you guys go up by 2s, but we'll just wing it on this one, okay? Over 5 up 2. And if I were to go over 10 and up 3, it would be about here. Sort of. A little lower than that, maybe. And we already decided that the graph does what? Goes up and to the right. So it looks sort of like this. It's kind of a funky graph. Wow.